Hello everyone. So today's LeetCode question is longest ideal subsequence. So this question falls under the LeetCode medium category, and the question says that you are given a string s consisting of lowercase letters and an integer k, and we need to find a string t which is ideal, and the ideal string is a string which is subsequence of the input string and also the absolute difference of any two adjacent letters in T is less than or equal to k, and we need to return the length of longest ideal string. Okay, and you can read the definition of subsequence over here if you are new to the subsequence topic, and note that the alphabet order is not cyclic, so the absolute difference would be 25 if it is a and z and not 1. Okay, so it is in a linear fashion. Okay, so let's quickly look up for the constraints, and the length of the input string is 10 power 5 and the k value is less than 25 and starts from 0. So we got a clear picture that your k value only lies between your English alphabet letters, and s consists of only lowercase English letters, right? So let's quickly hop on to the intuition and let's solve this problem. Okay, so let's discuss about the intuition. So the first things first is to find t, we need to know two things, right, which is already mentioned in the question section. So which is t is to be ideal, it should be first a subsequence, then the absolute difference of the adjacent characters, right? So j is I plus 1 or j can be I minus whatever stuff, right? The absolute difference between those characters should be less than or equal to k. K will be given in the question, which is given in the question, right? So in order to jump at this, so let me just give you a quick uh, math intuition for this absolute difference, right? So assume that this letter is A and this letter is B, right? A, B in the sense not the English alphabets, it's just a variable, right? So what can we tell? Mod of A minus B is less than or equal to K means that A minus B is less than or equal to K, or B minus A is less than or equal to K, right? So this is one of the important constraint to iterate or to get the next character in the subsequence, right? So let's just quickly discuss about the test cases and its outputs, and then we'll be coming back to our intuition. Okay, so we have our first test case and I've marked A because we'll be starting from there. Okay, so the given string is ACFGBD and your k equal to 2, right? So in the traditional fashion we'll start the subsequence from A, right? I chose A, which I marked in red color, and what are all the possibilities of the absolute difference letters, right? The first I am taking A, and on the right side can I go to B, can I go to C, because A to B's absolute difference is 1 and A to C absolute difference is 2, and I can also go to left. Why? Because I told you in the previous section here, in the previous section, if mod A minus B is less than or equal to K, you can go A minus B less than or equal to K or B minus A less than or equal to K, right? So I can go right or I can go left, right? Left is null. Why? Because there is no cyclicity in the English alphabet letters, right? It is in a linear fashion, so you cannot go below A or above Z, right? But in a cyclic fashion, if you go above Z, you will still arrive at A, right, in a circular manner. So that will be depicted as like this. So A, B, B is connected to C, C is connected to Z, so on to Z, and it is connected to A, right? Here it's not that case. So at A we only have two chances, right? You can either go to B, you can either go to C, right? So what makes more sense if you think non-algorithmically, right? If you look at the string, what makes more sense to take the next character? Because he only told us that the next character should be having a lesser difference than k, right? Not greater than that. So here I can see I have C, I have F, right? But I can only choose C because that is adjacent. So I'll go with C. So initially your string is, your I mean not the string, but yeah. So your T is equal to A. Now your T is equal to A and C because you chose C, right? Now we'll iterate, instead of A I'll take C, right? So I am not here anymore, I'm not here anymore, I am here, right, at this particular position, which is C. Now C has how many chances? I mean I am marking the letters which are only present in the string S. So C has two chances on the right, right, which is D and E, and C has two chances on the left, which is B and A, because absolute difference is 1, 1, 2 and 2. So does we have any chance to choose the next letter? Yes, we have. Why? Because we have D and we have B also, right, here and here. Okay, and now your left and right are having B and D, right? It doesn't make sense to choose A and D because they're extreme, right? We have to make a decision between B and D because their absolute differences are 1. Okay, so if I chose D, right, my string would be what? A, C, D, and after D we do not have any other letters in the string, so this will be a subsequence which is of length 3. But what if I chose B? The T will be modified to A, C, B, D and my output will be 4. So which is max of these both? A, C, B, D, right? So now what I'll do, I'll make a wise decision, I'll choose B, right, instead of my traditional D, I'll choose B, right? So A, C, B. Now B has two chances on the right, which is C, D. Doesn't make sense because C is not there on the right of B, and I mean right of B in the sense not in this particular test case, right? In the, I mean right means the next index, and on the previous side we have only A and nothing, right? So I can only choose D because C is already marked and C is also not present in the next position of B, right? So I'll choose D. So T is equals to AC PD. So now the string length is 4. That is your the first test case output. Coming over here, we still have K is 3 and we have ABCD. Obviously that will be the answer. Why? AB's absolute difference is 1, BC's absolute difference is how much? 1, C's absolute difference is 1, right, which is less than or equal to 3. That is output. So even if you want to trace it, you can still trace it by choosing the first letter as A, right? Okay. So the approach that we are going to discuss is, number of choices, right? So why am I telling it is number of choices? So our approach will be number of choices. Why? Because at a letter or character CH, we are going to write incrementing +1 to so on to k, and on the left we are checking for -1 so on to -k, right? And you have a wide variety of choices, right? You can choose 1, you can choose 2, you can choose 3, so on till k, and -1, -2, so on till -k. Makes sense, right? Okay, so you are dynamically checking, okay, will I get the longest subsequence with +1 or -1, +2 or -2, +3 or -3, right? So you have multiple choices and you need to keep check in parallel mode, right? So you have number of choices, you need to check everything in a parallel mode, and also you need to return the max length of the string, right? Not the marking of the string or the actual sub string or the subsequence. Max length of ideal string you need to, ideal subsequence or string sequence you need to get, right? So max length, parallel mode and number of choices, which makes us choose a recursive approach. And we already know that our constraints are 10 power 5 and recursion will be taking 2 power n time. So it doesn't make any sense, right? Okay, so even if it is using the internal stack space, it doesn't make sense. It tends to go into a stack overflow execution, and if you do a backtracking, you will still end up the same but with a lesser time complexity, a very small lesser time complexity than this. Then what is the most efficient approach? Dynamic programming, right? So the dynamic programming approach obviously uses something called buffer, and that buffer is a array where we store everything, right? Okay, now let me just also go with the approach itself, the dynamic programming approach itself, but I won't be coding anything. Instead, I'll be giving you the approach to write the code, and we'll be writing the pseudocode, not the actual code here, right? At the end, I'll display the code, but still, if you are watching till this point, you can still go write it on your own and still try to solve it on your own in the programming language, right? Okay, so let's go with the approach. So we are declaring an array, which is also called as DP array or whatever, right? So bear with me because I'm a Java user, right? You have your DP array, but what would be the test case? You chose something and you go left, you go right, right? So before going left and right, what we need to choose? You need to choose something called your character, right? Which I told in the test case discussion that we'll choose A or B or C, but we'll start with the first instance, right? That will make more sense, right? Okay, so I chose A in that first test case. No, I'll choose the A, right? So I will go from minus k, right? The minus k instances, because if I know a character, I'll go till minus k over here and I'll go plus k over here, right? Similarly, I'll go from minus k to the current character, which is not ch. Let's just tell some character, let's just say current, right? And we'll go till a plus k. We have these choices, and out of these choices, what I'll do is I'll store this particular current, right? This particular current value in the actual character value, the character that you chose, right? So that ASCII, or let's just say, because we are taking ASCII, right? So let me just also take, we are not taking ASCII, we are taking just a character, right? So dp of character, because we took a as character, let's just say tag character a, right, is equals to max of this particular dp of a comma your dp of your current, right? Why? Because the next instance will be depend upon previous instance, right? If a is 0, if a is 0, we'll increment it to 1, and if ac string, we have c as 0, but c's input is dependent upon a, which we got 1, and we'll increment 1 in the result, right? So we'll store max out of those both, right? Now why only max? Because you need to get the next occurrence to check, right? You chose a, and in the a's choosing, you went on choosing c over b, right? You have two chances. In a, you chose c over b. Now you need to store this c value in a. That we are doing over here. We are taking your dp of a and dp of c, and we are storing the value of dp of c. Now what I'll do after this for loop, result is equals to, I'll obviously increment the length, right? So the length will be stored in this particular character, right? So with a, how much length character I could store? 1, right? So that I'll also take max, right? I'll take my initial result and I'll increment the character, which is a plus, right? And at the end, this is the main driver logic, and at the end will return our result, right? So this is the approach. So now what we need to do is, A to B comma C, you chose C over B, right? Now at A you are storing 1 instead of 0 because you formed a string of length 1. Okay, now you move on to C, right, because you are choosing the next character in A, C, F, G, B, D or G, F, B, D, whatever. So you went on to A, you formed a string A or the subsequence A. Now you chose C, you stored the value of C in A, right, and now you went on telling that your result is A, okay, which is of length 1. Now the next character is C. Now in C you will take dynamically. I am not telling you you won't choose B, you will choose B, but eventually you will store the max value out of that. C we have D comma E and we have B comma A. Now you will choose D, and before choosing D you will move the value of D to C, right, and your result will be A comma C, which is of length 2, right, and after that the result would be ACBD because you dynamically choose before ACBD you will dynamically choose B, and result is equals to ACBD after B's iteration, right. So you will return 4 simply, right. The pseudocode is kind of similar, or we can just say it's simple. So as I've already declare your DP array over here. So for int I is equals to 0, I less than s dot length, which is your input string, and I plus plus, right. For get the character ch is s of I, and for j is equals to, or okay, so before, instead of getting the character, can we just get the integer value, right, which makes more sense for computation of k, right. So int k, or yeah, int k will be conflicted. Let's just take in ch s dot caret I, right. So j is ch minus k, j less than or equal to ch plus k, j plus plus. Do this, and now you will take dp of your current character, which is ch, max of dp of ch and dp of your j. You are dynamically choosing, right. Your result here, the result will be 0. The result is max of result comma, you pre-computed, right. So dp of your ch, right. After this you will return your result. Okay, so this is kind of a constant computation because this will take only big O of n star 2k, right, which is acceptable, right, because your k is equals to 25 at worst case, so 2k will be 50, right. So big O of 10 power 5 into 50, which is less than 10 power 6, so your solution will be accepted. So if I am considering the bigger complexity analysis, it is still big O of n, right, because k and 2 are constants, so it is still big O of n, right. So we can tell that this is one of the most optimized approach and very small pseudocode. So I'll be putting out the Java code and the C++ code in the next upcoming slides, so you guys can go through over there. And please, before seeing the actual code or the pseudocode here, please try to implement upon your own programming language choice and try to get the intuition on the test cases also. Okay, so I will still remind you to also check out the recursive and the iterative approaches for this DP array storage, right, because that will also be asked in the interviews first phase of tackling the question, and then you'll eventually go to backtracking, and then you eventually approach the dynamic programming concept. Don't forget to like, share and subscribe to the channel, and make sure you just keep looking out for the videos of LeetCode Daily. Thanks for watching.